Alright, let's talk about Chapter 7. It's an introduction to SQL, or the structured query language. In this chapter you'll learn basic commands and functions of SQL, how to use SQL for data administration, create tables and indexes, how to use SQL for data manipulation, adding, modifying, deleting, and retrieving data, and how to use SQL to query a database for useful information. Ideally, a database language will allow you to create a database and table structures that perform basic data management chores, add, delete, modify, and so forth, and perform complex queries designed to transform your raw data into useful information. Moreover, a database language must perform such basic functions with minimal user effort, and its command structure and syntax should be easy to learn. It should be portable. That is, it must conform to some basic standard so a person does not have to relearn the basics when moving from one management system to another. SQL meets these ideal database language requirements really well. SQL functions fit two broad categories. Alright, data definition language, or the DDL. SQL includes commands to create database objects such as tables, indexes, and views, as well as commands to define access rights to those database objects. Some common data definition commands you will learn are listed in Table 7.1. It is a data manipulation language, or DML. SQL includes commands to insert, update, delete, and retrieve data within the database tables. The data manipulation commands you will learn in this chapter are listed in Table 7.2. Let's look at 7.1 first. Here's your command options for creating and deleting actions. That's your DDL, or data definition commands, that we talked about first, to create your database and table objects and views. And then there is your data manipulation language commands: insert, select, update, delete, commit, rollback. These are in your book on pages 237 and 238. Alright, again, SQL is relatively easy to learn. Its basic command set has a vocabulary of fewer than 100 words. Better yet, SQL is a non-procedural language. You merely command what is to be done. You don't have to worry about how it's done. The American National Standards Institute, or ANSI, prescribes a standard SQL. The current fully approved version is SQL 2003. The ANSI SQL standards are also accepted by the International Organization for Standardization, or ISO, a consortium composed of national standard bodies of more than 150 countries. Even though there are several different SQL dialects, the differences are minor. Whether you use Oracle, Microsoft SQL Server, MySQL, IBM's DB2, Microsoft Access, or any other well-established RDBMS, a software manual should be sufficient to get you up to speed if you know the basic material presented in this chapter. At the heart of SQL is the query. The query is a spur-of-the-moment question. That's what we learned in Chapter 1. But actually in SQL, the word query covers both questions and actions. Alright, most queries are used to answer questions such as what products currently held in inventory are priced over $100, and what is the quantity on hand for each of these products, or how many employees have been hired since January 1st, 2008 by each of the company's departments. However, many SQL queries are used to perform actions such as adding or deleting tables, rows, or changing attribute values within tables. Still, other queries create new tables and indexes. In short, if a DBMS is a query is simply an SQL statement that must be executed. However, before you can use SQL to query a database, you must define the database environment for SQL with its data definition commands. Alright, so this figure is a database model which reflects the following business rules. A customer may generate many invoices. Each invoice is generated by one customer. An invoice contains one or more invoice lines. Each invoice line is associated with one invoice. Each invoice line references one product. A product may be found in many invoice lines. You can sell more than one hammer to more than one customer. A vendor may supply many products. Some vendors do not yet supply products. For example, a vendor list may include potential vendors. If a product is vendor supplied, it is supplied by only a single vendor. Some products are not supplied by a vendor. For example, some products may be produced in-house or bought on the open market. So, as you can see in the figure, the database model contains many tables. However, to illustrate the initial set of data definition commands, the focus of attention in the book will be product and vendor tables. Alright, so a task will be completed before using a new RDBMS. You need to create your database structure, create physical files that will hold your database. This can differ from one management system to another. Authentication is a process of the DBMS using to verify that only registered users can access the data. And required for the creation of all tables, users should log on to the database management system using a user ID and password created by the database administrator. Alright, the database schema is a logical group of database objects related to each other. Alright, and the command here is create schema authorization. Okay, seldom used directly. But this is the ANSI standard to define creating a database schema. Alright, the data types. Numeric, character, date. Alright, so you have numeric, which of course is your numbers. You have your char and your varchar, one being fixed length and the other being a variable length. And then of course your date will hold dates and times. And when you're creating your table structures, you use one line per column definition, one attribute. Use spaces to line up attribute characteristics and constraints. Table and attribute names are always capitalized by convention. Features of table creating command sequence, not null specification and unique specification. You have to specify whether it's the primary key or not and that sort of thing. Syntax to create a table is create table, table name, open and close parens there, which could have all of your attributes inside, and closing semicolon. I want to go back here to your data types. If you have a table in your book, I thought it was in the slides, but it's on page 244 that talks about your data types. Let's talk about those real quick. Numeric indicates that numbers will be stored with 2 decimal places and maybe up to 7 digits long if you put number and in the parens 7,2. So you have 2 decimal places and up to 7 digits, including the sign and the decimal place. Integer, maybe abbreviated as INT. They are whole counting numbers, so they cannot be used if you want to store numbers that require decimals. Small int like integer, but limited to integer values up to 6 digits. Decimal like number, but the storage length is a minimum specification. That is, greater lengths are acceptable, but smaller ones are not. So decimal 9,2, decimal 9, and decimal are all acceptable. Char is fixed length. Varchar is a variable length characters, where you put your string data in. And then date, of course, stores dates in the Julian date format. and that's on page 244 in your book. And then going back to creating tables, primary key and foreign key. Primary key attributes contain both a not null and a unique specification because it is your unique identifier for the record, and it cannot be null. You must have that unique identifier for every record. Your RDBMS will automatically enforce referential integrity between foreign keys and primary keys. Referential integrity, what that means is your table with your primary key is the parent. If it's used as a foreign key in another table, that's the child table. And you cannot delete a parent if it has records in the child table. So say you had a instructors table and a class schedule table. So if you had an instructor named Mr. Jones and he was assigned to 4 classes over in the class schedule table, you cannot delete Mr. Jones because he is assigned classes. In order to be able to delete Mr. Jones as an employee, you would have to take his name off those classes, delete those records in the foreign key table where he is assigned classes, and then once those records are gone, then it would allow you to delete Mr. Jones. That's what referential integrity does. It says, okay, you can't delete me if I have children over here as a foreign key. Alright, command sequence ends with semicolon always. ANSI SQL allows uses of following clauses to cover cascade, set null, or set default. On delete and on update. And it gives you some create table examples of how the information would be set up on page 246. 246 in your book. It shows you the vendor table and the product table, the statement that would be needed to create those two tables with the attributes listed and their values and data types set. Alright. So not null ensures the column does not accept nulls. You must enter a value. Unique ensures that all values in the column are unique. Default assigns value to attribute when a new row is added to a table. And check validates data when attribute value is entered. Okay, when the primary key is declared, the DBMS automatically creates unique index. A composite index is based on 2 or more attributes and prevents data duplication. Syntax to create SQL indexes: create index, the index name, on, and then the table name. Such as create index first name on vendor table. Vendor would be the table name. Alright, syntax to delete an index is drop index and then the index name, such as first name. Alright, data manipulation commands. You have the insert command that inserts data into a table. Syntax is insert into, table name, and then the values. Used to add table rows with null and not null attributes. Commit is the command to save changes. So syntax commit work ensures database update integrity. Data manipulation commands. You have select, command to list contents. Syntax select column list from table name. The wildcard character, the asterisk, substitute for other characters in your command. Your update command to modify data is update, table name, set, column name, equal, expression, column name equals expression, where condition list. Yeah, I know that one's a little bit confusing. So let's do an example of that one. You would have something like update product, set P underscore end date equal to January 18th, 2014, where P code is equal to 13-Q2/P2. Okay, so that's an example there of a data manipulation command for update. You can look at that, select and update on page 257 in your book. You can put another thing you could do is update product. Again, you're updating the product column list. Set P underscore end date to January 18th, 2014. P underscore price equals $17.99, and P underscore min equals 10, and where the product code equals 13-Q2/P2. So it tells you to update your product where P code is 13-Q2/P2 with the end date, P price, and P min values that it lists here when the criteria meets the where statement. The where condition specifies the rows to be selected. Alright, the rollback command. If you have not used the commit command to store the changes permanently in the database, you can restore the database to its previous condition with the rollback command. Rollback undoes any changes since the last commit and brings the data back to the values that existed before the changes were made. Alright, so the syntax is simply rollback and the semicolon. The delete command. Alright, it shows you the syntax there. Delete from, and you give the title name, where, condition list. So an example of that would be delete from product where P code equals BRT-345. In this example, the primary key value lets SQL find the exact record to be deleted from the product table. However, deletions are not limited to a primary key match. Any attribute may be used. For example, delete from product where P underscore min equals 5. It will check the product's table contents again to verify that all products with P underscore min equal to 5 is deleted. Remember, the delete is set oriented command and that the where condition is optional. Therefore, if you do not specify a where condition, all rows from the table will be deleted. Alright, select subqueries. Your syntax is insert into table name, select column list from table name. Used to add multiple rows using another table as a source. The select command acts as a subquery and is executed first. And then the subquery, query embedded nested inside another query. Alright, when you have the nested or embedded queries, the inner query is always executed first. Let's see if it gives an example. No, I don't think it does. Given the previous SQL statement, the insert portion represents the outer query, and the select portion will represent the subquery. You can nest queries many levels deep. In every case, the output of the inner query is used as the input for the next higher level query. The values returned by the select subquery should match the attributes and data types of the table in the insert statement. If the table into which you're inserting rows has one date attribute, one number attribute, and one character attribute, the select subquery should return one or more rows in which the first column has date values, the second column has number values, and the third column has character values. Alright, restrictions. Following syntax enables to specify which rows to select. Select column list from table list where condition list. Alright, so you would do something like select P underscore D script, P underscore end date, P underscore price, and V underscore code from product where V underscore code equals 21344. And then if you look at that example on 260, it returns 3 records there in figure 7.4. It's used to select partial table contents by placing restrictions on the rows. The optional where clause adds conditional restrictions to the select statement. Adding conditional restrictions is used on character attributes and dates. With the comparison operators, you have your equal to, less than or equal to, greater than or equal to, and not equal to. So you can do something like P underscore descript, P underscore end date, P underscore price, and V underscore code is what you're selecting from product where V underscore code is not 21344. And then it returns the values shown in figure 7.6 on 262 in your book. And then it has another one there where you do select P underscore D script, P underscore QOH, P underscore min, and P underscore price. Okay, what you're doing there in the select statement is selecting the columns that will be displayed from the product table where P underscore price is less than or equal to 10. And in figure 7.7 on page 262, you can see the records that were returned when you select those 4 columns and make the constraint on it P underscore price less than or equal to 10. Alright, comparison operators with computed columns and column aliases. SQL accepts any valid expression or formula in the computed columns. An alias is an alternate name given to a column or table in any SQL statement to improve readability. Computed column, an alias, and date arithmetic can be used in a single query. Alright, so if we look at using computed columns and aliases, and we want to select P underscore D script, P underscore QOH, P underscore price, P underscore QOH times P underscore price from the product table. And then if we enter that command, it will generate the computed information that we have in figure 7.10 on page 264. It will give you the columns that you asked for, and then the one that it computed is there at the end, and you computed it by using P underscore QOH times P underscore price. Alright, you can give it an alias by doing P underscore D script, P underscore QOH, P underscore price, P underscore QOH times P underscore price, and show that as total value. Alright, and you'll get the results there on page 264 in figure 7.11, where the computed values are now shown in a column named total value there. It's the same as the previous example, except we gave an alias name to the computed column. Alright, the rules of precedence establish the order in which computations are completed. We will always perform operations within parentheses. then power operations, multiplications and divisions, and then additions and subtractions. It shows you your arithmetic operators there in table 7.7, and then remember your order of precedence. Within parentheses, then we have the power operations, then multiplication and division, it comes next, and then addition and subtraction is last. And it will work from left to right. It will do this stuff in order from left to right. Arithmetic operators. If we do logical operators, and or and not, if we look at one for or, alright, alright, so what it's saying here in this one, if you look for V underscore code 21344 or V underscore code 24288, it'll look for both conditions. You will select P underscore descript, P underscore end date, P underscore price, and V underscore code. That's the 4 columns that it will show from product, where V code is 21344 or 24288. And it shows you there on the bottom of 265 the syntax for that query, and it shows you here the results of that query. The logical AND, alright, has the same syntax requirements as the OR. However, it will give you, it will generate both. It must meet both requirements. So if you use P underscore descript, end date, price, and V code from the product table, where the price is less than 50 and the end date is January 15th, 2014, it must meet both requirements before it will show it. The price has to be less than 50 and the end date has to be greater than January the 15th. So it'll have to meet both of those requirements on an AND. Alright. And then the logical NOT is used to negate the result of a conditional expression. So, the one on the very bottom there, oh, that's combining and or. We'll come back to that one. Let's talk about the NOT statement there on the bottom of page 266. It says select, and it has the wildcard. That means it'll select all columns from product where V code is equal to 21344, but it's got the NOT in front of it, so it'll return all records that does not have the V code of 21344. Okay. Now combining and or. Let's see. You have P underscore descript, end date, price, and then you have your V code from the product table, where P underscore price is less than 50 and P end date is greater than January 15, 2014, or the V code is 24288. Okay, so what's going to happen here? You got two conditions going on. Either the price has to be less than 50 and end date greater than January 15th. Both of those conditions have to be true for it to allow records from that statement. Or the V code has to equal 24288. So it's going to show all records where the V code is 24288 and all records that match up with the price being less than 50 and the end date being greater than January the 15th. Alright, and then we have some special operators. Between is used to check whether an attribute value is within a range. Is null is used to check whether an attribute value is null. Like is used to check whether an attribute value matches a given string pattern. In is used to check whether an attribute value matches any value within a value list. Exist is used to check whether a subquery returns any rows. Okay, there are some examples in your book of these. For the between operator, you can have the select wildcard, which will select all your columns from product, where the price is between 50 and 100. So it would catch everything between 50 and 100. If it doesn't support between, you can use price greater than 50 and price less than 100. We'll make that work. You can use the and there. The is null special operator. Select P code, P descript, and V code from product where V code is null. So if V code is null, it will show all those records. Alright, so for a like statement, you can select vName, vContact, vAreaCode, and vPhone from vendor table, where vContact, like, and then you have the Smith % there. It will check the original vendor with records that has Smith in the name. So if you put, you can check for Smithsonian, Smithson, anything like that where it's like Smith. Alright. Let's see for the N. Alright, so many queries that will require the use of the logical operator OR can be done with the special operator IN. So if we had the select all columns with a wildcard from product where the V code is 21344 or 24288, you could do that same action with select asterisk from product where V code in, and in the brackets 21344 24288. This is on page 270 at the top of the page. And then exist. The exist operator can be used whenever there is a requirement to execute a command based on the result of another query. So select asterisk from vendor where exist, select asterisk from product where PQOH is less than or equal to P underscore min. And that would select all vendors that fall into the category where their QOH value was less than their min value, or less than or equal to their min value. Alright, advanced data definition commands. Alter table is to make changes in the table structure. Keywords used with the command are add, which adds a column, modify, which changes column characteristics, drop, which would delete a column. It's used to add table constraints and remove table constraints. Alter can be used to change the data type. Some relational database management systems do not permit changes to data types unless the column is empty. And then the basic command there is alter table, table name, modify column name, and the data type. There's an example there on 271 where it's got alter table product, modify v code to a char 5. Again, you can use it to change the data characteristics. Changes in column characteristics are permitted if changes do not alter the existing data type, such as here you got your column characteristic. Adding a column, use alter and add. You do not include the not null clause for new columns. Dropping a column, use alter and drop. Some management systems impose restrictions on the deletion of an attribute. And it shows you an example of adding a column there on page 272 in your book where it's got alter table product, add P cell code char 1, and then at the top of the next page it's got alter table vendor drop column v underscore order. You can update. Command updates only data in existing rows. If a relationship is established between entries and existing columns, the relationship can assign values to appropriate slots. Arithmetic operators are useful in data updates. In Oracle, rollback command undoes changes made by last two update statements. And it's got you some examples of update statements. There on page 273 in your book. It's got an update statement where you update product, you set the P cell code to 1 if the P code is 2232 QWE or 2232 QTY. The cell code would be set to 1. Alright, SQL permits copying contents of selected table columns. Data needs to be re-entered manually into newly created tables. Data need not be re-entered manually into the newly created tables. The table structure is created and rows are added to a new table using rows from another table. Excuse me. And it shows there on page 275 an example. Create table part. And it copies those values from it creates that table part and then insert into part. And then it has some more examples there on 276 where it has your create table part as select, and it's got all these columns selected from product. And it would throw it into the new part table from the product table. Alright, I'm sorry for the interruption. Okay. The alter table followed by a keyword that produces the specific changes one wants to make. Options include add, modify, and drop. Your alter table An example is on the bottom of page 276. Alter table part by adding a primary key part code. Or alter table part, add foreign key V code which references back to vendor. The drop table deletes tables from the database. You would put drop table part and it would delete the entire table. Alright, and you can drop the table only if it's not the one side of a relationship, the primary key side of the relationship. Because the database management system generates a foreign key integrity violation error message if the table is dropped when it was being referenced as foreign keys in other tables. Okay, logical operators worked well in a query environment. SQL provides useful functions that counts, finds mins and maxes, and calculates averages. SQL allows users to limit queries to entries having no duplicates whose duplicates may be grouped. Alright, now order by clause is useful when listing order is important. So you would have something like select P code, descript, end date, and price from product, and you order by the price. So it would be like order from smallest to largest selling price. Cascading order sequence is a multi-level order sequence. It is created easily by listing several attributes separated by commas after the order by clause, such as select last name, first name, initial, area code, and phone number from employee, ordered by last name, then first name, then initial. Okay? And it gives you a result there in figure 718 on page 278 of how that would work. And where you can see it is in the Smith. You have two George Smiths and a Janine. And then the Georges are alphabetized further by the A and the K of their initials. And that is called cascading order sequence. Distinct produces list of values that are unique. So you could have something like select distinct V code from product, and it will list all of the V codes, but it won't duplicate any. Okay, the results will be there in 720 on 279. It lists all the V codes without duplicating any of the V codes. It gives you the distinct values. Alright, and then we have the count, min, max, sum, and average functions. Your aggregate functions. Alright, count is used to tally the number of non-null values of an attribute, and it can be used in conjunction with distinct. It shows you an example there in 721, and it says select count distinct V code from product, and it gives you 6 there in that first example. And then it says select count distinct V code from product where price is less than or equal to 10, and it tells you that the answer there is 3. You have 3 distinct V codes that has a price less than 10. Okay. Alright, max and min works like you think they would work, finding the lowest or the highest values. So you would have something like select P code, descript, and price from product where price equals max price. Or you can just do something like select max price from product, and it would give you the maximum price that's in the product table. Again, you could do the same thing, select min price from product, and it would give you $4.99, which is the minimum price that is showing up in the table. Alright, group by, oh, I didn't finish up. Okay, sum. The sum function computes the total sum, so you can sum the customer balance and from the customer table and get the value there. And then average, of course, average function is the arithmetic mean for a specific column. And you would do something like select average P price from product, and it would average all of your P prices. It would add them up and to get the average of 56.42125. Alright, now group by. Rows can be grouped into smaller collections quickly and easily using group by. It's generally used when you have attribute columns combined with aggregate functions in the select statement. You would have something like select V code, P descript, and P price from product, and then you would group it by V code. And it shows the results there. In 726, figure 726 on 286. First it shows you getting an error, and the second one is the correct way to do it. The having clause, it's a useful expression of the group by feature is having. The having clause operates very much like where in the select statement. However, the where clause applies to columns and expressions for individual rows, while the having clause is applied to the output of a group by operation. So you would have something like select V code count, distinct P price, average P price from product, group by V code, and then it would give you the results there on page 287, figure 7.27. It's grouping it by V code and giving distinct P codes and the average price. Alright, joining database tables. The ability to combine or join tables on common attributes is perhaps the most important distinction between a relational database and other databases. A join is performed when data are retrieved from more than one table at a time. To join tables, you simply list the tables in the from clause of the select statement. The DBMS will create the Cartesian product of every table in the from clause. Alright, it gives you an example, a simple example there, where you're selecting P descript, P price, V name, V contact, V area code, and V phone from product and vendor, where product V code equals vendor V code. So when the V codes match in the two tables, you will get the results of the join would be figure 7.28. Alright, and then joining tables with an alias. Maybe you should identify the source table from which the data are taken. An example of that is something like select P descript, price, V name, V contact, V area code, V phone, product P, vendor V, and then you got p.vcode equals v.vcode, order by p price. So it's giving the tables the aliases p and v, and then in the where part, all you've got to do is p dot whatever attribute you're trying to connect with that table. Alright, a recursive query. A table is joined to itself using alias. Use aliases to differentiate the table from itself. Alright, so you have something like this employee table at the bottom of 290, and then you would do something like e.employee num, e.employee lname, e.employee manager, m.employee lname from empe, empm, where e.emp manager equals m.emp emp num, and order by e.emp manager. And then it would give you, it would use an alias to join the table to itself. In figure 7.31 would be your results. Alright, that concludes the content lecture of Chapter 7. I know it's as clear as mud right now, but I'm going to post a video actually working in MySQL, creating tables and queries that will help you to understand this a little bit better.